Hi everyone, hope you are doing well. Today we are displaying here some of the activities which are related to mathematics. People used to be in a misconception that mathematics is not that interesting subject, or say it is not that much related to day-to-day life activities. But here in our school we relate every mathematical aspect with some very low cost teaching aids, or you can say the working models and the non-working models which can explain a mathematical concept beautifully, and it is well understood. I will display some of the models with you one by one. Likewise, when we have to display with a cylinder, it's a very simple model of solid cylinder, and one can see it very easily that here is the face, there's the curved surface, and again here is a circle, the base. Again, when we go to in common language, what we say, pipe. So pipe is a hollow cylinder, and you can see this here, it is the model of a pipe. And with these type of models, when we combine all these solids, sometimes we find the examples of conical and conical tent with the base of a cylinder. We find it very easily that this is the cylinder having a top of cone, and if we detach it, this is simple. So finding it out that surface is the volumes, or say the combination of one solid with another, like cylinder and hemisphere, it will be in this way. Again, if we move to some two-dimensional figures, these are very good examples of these two, and we can paste them on board with using a magnet. I will show it here. Likewise, here this is another one. We can put it in this way, showing different color, and if we want to use it with the same color, we can use it in this way. Likewise, triangles, or say the figure which we say here like this, and if we want to show some activity using it, we can fix it here. Like here we can show in this the different parts of his circle. Likewise, here it is another one. All they are detachable, and they explain it beautifully that how it is a semicircle. Semicircle is fixed. Then another part, if you fix it here, then it is here. Then using the angle and the pie chart in statistics, a lot of activities we used to learn with this type of teaching aid. And believe me, this whole is developed here. Another, like we explained the solids cube, volume of a cuboid. So it's very easy to explain the volume of solids. So the volume of a cuboid here. See here in this one, in this cube, every single cube, it's a unit cube. So when we detach them and we count them one by one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So it shows that volume of this cuboid, it is 21 cubic unit, whatever is the unit of this one. We can detach them, and again we can add them, and again we form a cuboid with the help of different cubes. Likewise, here it's a beautiful model which can explain you see, as we have quadrants in two-dimensional geometry, we have octants in three-dimensional geometry. So this model is beautiful model which can explain whole the three-dimensional geometry using this one, and it shows how octants are there. It's become sometimes difficult when we imagine some three-dimensional figure, and this octant, it's sometimes become difficult to imagine in comparison of quadrants. But using this very low cost, this is simply we have used these small cardboards, and we have cut them and we have pasted them, and everywhere you can see here that 1, 2, 3, likewise x-axis, x-dash axis, negative axis, positive axis, everything can be seen here. And using some sticks, every concept of trigonometry, three-dimensional geometry, we can use it, whether it is a intersection of a line and a plane, whether it is intersection of two planes, whether the condition of perpendicularity of two planes, or whether the angle between two planes. Mean all aspects all mathematical concepts of three-dimensional geometry, they can be explained using this very low-cost teaching aid and just one pin, you can say, or a spoke of a cycle. That spoke of cycle represents a line, and this hole represents the octant of plane surfaces. Another one, like you see, our kids had developed this one. This is a beautiful model which express the volumes and areas of different things. Here is another one. It's a very good example of day-to-day activities of using trigonometry, where we find such distances or the height where it's not possible to reach or to measure with the help of physical things. Likewise, here is the clinometer. It's again used in the trigonometrical measurements or to find out the different type of distances and angles which are not possible to measure using some other activities. This is a very famous activity which we say the Tower of Hanoi. Once it used to be a very famous problem in mathematics, but using these cylinders and the dishes and this one like this, we complete this activity, and it's very interesting when we repeatedly do it with the help of different discs by using this one. Here is another very small model, simply used plywood and some mica, and it shows that how the size and symmetry relate to each other. It's a small one, then the larger one, then the larger one, and the larger one. Apart of that, we had another clinometer. It is using this type of measuring, and here we can use with the help of this protector, and this one we use with the help of to find out to show the angles here. Another one what we use in the symmetry of three-dimensional solid figures. You can this is the smaller one chair. This is the shape and the size of both one. They are same, but the size is different. I would say, sorry, shape is same, but the size is different. We say the figures are in symmetry, and using some other dimensions and all measurements of these two, we prove that symmetry in three-dimensional figure. How does it take place? Likewise, when we use different type of another thing, like here, it's very easy to say that this is 1/3. When we study fractions, this is 1/3. Now we take another one, then it becomes 2/3. Again, if I make it here, it becomes 2/3, and if I put it here, it becomes the complete one. Here, if you come, this shows 1/4. If I take out one more another, it is 1/2 now. Again, now it is 3/4. Again, if I note, it becomes the complete one. Here again, if I take it, now it's half, and again, if I join it, it's complete. Here, this is still so explained it so beautifully. Likewise, here I have taken out the one for example. So here now 1/12 part means this is fraction, which I would say this is 1/12. So now it is 2/12. In simple one I can say it is 1/6. Then again this one. Likewise, I can explain beautifully and very easily to understand how a fraction is there. Likewise, here different type of triangles. Here is right angle triangle, and here it is. And in this logos teaching it is nothing. It's an iron board, and with iron board everywhere we are using simple cardboard here. And after that simple cardboard, here is a very small part of magnet, which can be used to detach it some part and again to paste it some part here. And all geometrical figures. Likewise, here it is diagonals of a rectangle. Here it is. This is a parallelogram intersecting this. And here again, it's a triangle like this. It can be used. Again, it's another triangle like that with the nomenclature again. and here is again a parallelogram. Here can say simply a circle here. So all geometrical figures it can be used here. Likewise here A, B, C, D for a cyclic quadrilateral or the points lying on the same circle. Here there are some on the display of this board. There are different type of activities of tiles, which are very famous activities in mathematics. Using tile, what we do, how the shapes are changing, when we join them, how the shapes are becoming a part of that. Otherwise, here it is like this shape, again then this type of triangular one, then using 4 copies, then using 4, 9 and 15 copies, how all these type of things can be explained in that way. So it's about mathematics, what a misconception we have brought. It's not like that it's that damn difficult one, but the only thing is how much we can relate it to our day-to-day activities and how much we can visualize it. See, when we try to understand something, the power of visualization is the main thing which can be used to explain some difficult thing. Because what we can see, we can understand, that is the issue. So up to what extent we can visualize, we try to visualize mathematics in our classrooms, and these are some small displays of that. Next time we will try to come up with some more models which would be explaining different mathematical concepts in a very easy way. Thank you.